Hello everyone, I welcome you all to this class. This is mathematics class, and in this class I will show you how to use the method of variation of parameter to solve a non-homogeneous second order ordinary differential equation. Assuming that you have a non-homogeneous second order ordinary differential equation and you have gotten your complementary solution, you want to get your particular solution, then the method of variation of parameter will help you to get the particular solution of that second order non-homogeneous ordinary differential equation. So now let y sub c, which equals c1y1 plus c2y2, be the complementary solution of a second order ordinary differential equation. Then the particular solution is given by y sub p equals a of x y1 plus b of x y2, and this a of x and b of x are just arbitrary function. So in this method of variation of parameter, you get the particular solution from the complementary solution. Now we are going to change this constant c1 to a function of the independent variable, arbitrary function of the independent variable. So instead of this c1, I'll use a function of the independent variable to replace it, a of x. So I'll still have my y1. Then instead of this c2, I'll replace with another arbitrary function of the independent variable, b of x. So I'll still have my y2. This is how you get the particular solution from the complementary solution using the method of variation of parameter. Once I have done this, then by the method of variation of parameter, by keeping your y1 and y2 and differentiating your arbitrary constant once, this result will be equated to what? 0. We give you 0. This result will be equated to 0. Then, and by keeping the first derivative of your arbitrary constants and differentiating your y1 and y2, it will give you the f of x, which is that non-zero function of the independent variable. I'm going to use this method to solve this particular example. Then say use the method of variation of parameter to solve the ordinary differential equation y prime prime plus y equals tan x. So this is what we want to do. So let's start the solution. So I've written it down. The first thing you have to do is to find the complementary solution. Next, you know how to find your complementary solution. You find the complementary solution by taking the homogeneous part of this equation. That is setting this one to be 0. You take the homogeneous part. So you say set y prime prime plus y equal to 0. This is, you set this to 0. You will now have a homogeneous ODE. So you are going to use the homogeneous part to find the complementary solution. So now I will get what I call auxiliary equation. Auxiliary equation, you get the auxiliary equation by replacing your y with another letter. You can use m, you replace it with another letter. Then the power on those letters will be the derivative of y. So instead of this y, I'll put what? M. Then what will be the power? I'll count the derivative. How many derivatives do you have here? 2. So I'll put 2 on m. Plus, I'm replacing my y, right? I'll replace it with m. Do you have any derivative on y in this one? Do you have any derivative? No derivative, right? No prime. So I'll put what? 0. So m raised to power 0 will give you what? 1. This will be 1 equal to 0. So this implies I can move positive 1 to the right? It will change to negative 1. So this implies that your m squared equals negative 1. Right? To get m, you take the square root of both sides, right? So this implies m equals plus or minus square root of negative 1. I took the square root of both sides to get m. So what is square root of negative 1? Square root of negative 1 is what? I, right? So square root of negative 1 is I. So this is plus or minus what? This is plus or minus I. So this implies that m equals, because I got is what I got like this is a complex number, so I will try to write it in terms of its real part and the imaginary part. So because I don't have a number here, no number before the no number here before I, so it means that the real part is just 0. So that this is something as 0 plus or minus what? I. So y sub c will be what? Y sub c, which is the complementary solution, will be given by exponential alpha into c1 cosine beta x plus c2 sine beta x. So this is the general form of the complementary solution when you get what? When you get a complex root. The root we got here is a complex root. So if you get a complex root, this is how your complementary solution will look like. This alpha is the real part of that complex number, while beta is the imaginary part. And for this beta, you are going to take the positive part of the imaginary, because we are having plus or minus I, right? So the coefficient of I, we are going to take the positive part of it, that's positive 1, the coefficient of I, which is the imaginary part. So this one now will be exponential 0, because the real part is 0, into c1 cos the positive part of the imaginary, that's the coefficient of I, the positive part of it is 1. So we put 1 here, we have cos x plus c2 sine x. So this will be what? Exponential 0 is what? Exponential 0 is 1. So this implies that y sub c is equals to c1 cos x plus c2 sine x. I've gotten our complementary solution. Then the particular solution will be what? Then, now, after getting your complementary solution, then the particular solution, you are going to get it from the complementary solution, right? So since we have gotten our complementary solution, that's why I wrote then the particular solution is given by y sub p equals, so instead of this c1, I will replace it with what? Arbitrary function of the independent variable. Independent variable in this ODE is what? X. So arbitrary function of x. So this will be, I will write a of x instead of this c1. Then I will have my y1 now. Okay, let me just write this y1 plus, this one will be b of x, this will be y2. So this will be equal to what? A of x. Your y1 is this. This cos x will be your y1. This will be cos x plus b of x. Y2 is this, sine x. Now by the method of variation of parameter, you are going to do what? A of x prime y1 plus b of x prime y2 equal to 0. And you differentiate your arbitrary constant, differentiate a of x, differentiate b of x, and keep your y1 and y2. You get this first equation, equate it to 0. Then the second step is keep that first derivative of the constant. This time around, what you are going to differentiate is your what? Y1 and y2. So I'm keeping the first derivative of the constant, I'm differentiating my y1 and y2 this time around, and that result will be equated to what? F of x. F of x is that non-zero function of the independent variable at the right hand side. So remember the ODE we had was what? Y prime prime plus y equals what? Tan x. So this tan x is my f of x. So let's substitute. So in this first line I wrote, this implies what? A1 of x. What is my y1? My y1 is what? Cos x, right? Plus b prime of x. What is my y2? My y2 is what? Y2 is what? Sine x. sine x. Then this will be equated to what? This should be equated to what? 0. This gives us what? Let me call this one equation 2. Right? Let me call this one equation 2. And call this this first one, let me call this equation 1. The y of p. Right? Then the next one, and the next line is what? You are keeping the first derivative of the arbitrary constant, a prime of x. Then this time around, what you are going to differentiate is what? You are going to differentiate your y1 and the y2. Differentiate y1. y1 is what? y1 is what? Cos x. If you differentiate cos x, what will you get? Negative sign. You have negative sine x. Plus, you are keeping your the first derivative of the arbitrary constant, and we are differentiating what? y1 and y2. So differentiate y2. y2 is sine x. Differentiate sine x, you get what? Positive cos x. So this will give you what? You equate it to f of x. What is this f of x? This non-zero function here of the independent, which is tan x. Tan x. So I'll call this one equation 3. Now you are going to make the b prime of x the solution to the formula from equation 2. From 2. What is your b prime of x? B prime of x is equal to, so if I want to make this the subject of the formula, what do? I'll move this to the right. So if I move this to the right, change to negative. Negative a prime of x cos x divided by, because when I move this to the other side, I will now have this quantity. Then to get this b prime of x, I have to divide both sides by what? Sine x. So divided by what? Sine x. So with this, I've made the b prime of x the solution to the formula. I'll call this one equation 4. You now substitute this equation 4. Substitute this equation 4 in equation 3. Substitute 4 in 3. So this implies, so instead of this b prime of x, this is what I'm going to put. So let me write this first. A prime of x. So this implies this will be what? Negative a prime of x sine x. And this will be what? Plus, okay, because I have to put my b here and I'm having negative sign here. Since I have negative sign, so I put it here. So this will be negative a prime of x cos x divided by sine x multiplying what? Multiplying cos x. Multiplying cos x. Cos x. Equated to what? Equated to tan x. What is tan x? Tan x is what? Tan x is sine x. Sine x divided by cos x. So that's tan x. So what we're going to do, let's multiply both sides by this denominator here, by sine x. So if you multiply both sides by sine x, what will you get? So multiply here by sine x, you'll be having sine squared. So I have negative a prime of x sine squared x. So multiply here by sine x, what will happen? This sign here will cancel it. So you now have negative a prime of x cosine of what? X. I have cosine here. So let's multiply cosine multiply cosine. I have cosine squared. Right? Then equated to multiply here by sine x, because I'm multiplying everything here by sine x. I multiply this by sine x, multiply this by sine x. I'll multiply this by sine x, so I have sine squared x divided by cos x. So this implies, so negative is here. So I have negative a prime of x, negative a prime of x. I can factor it out. So this implies negative a prime of x into sine squared x plus cos squared x equals sine squared x divided by cos x. So what will happen? This becomes 1. Sine squared theta plus cos squared theta is what? 1. So this becomes 1. So this implies negative a prime of x, negative a prime of x is equal to, this will be sine squared x divided by cos x. So let's multiply both sides by negative, multiply here by negative, multiply here by negative. So this implies I will now have positive a prime of x equals negative sine squared x divided by cos x. So what we are going to do is to get I want my a of x, I want to get this constant. So how do I get it? I have to what? For me to get this constant, I have to integrate both sides, right? This implies integral of a1 prime of x dx equals, I will integrate here, integral of negative sine squared x divided by cos x. So this one I've written my, because I want to clean the board, I've written this b prime of x somewhere here so that I can use it. Then this a prime of x, let me call it another equation. Let me call it equation 5. So I can now clean the board. So remember, I want to integrate this, right? So integral will cancel the derivative on the a prime. So what will happen? You will now have your a of x. A of x equals, now here, negative sign can come out, right, of the integral. So I have negative integral of this sine squared x. Sine squared x, I can write it as what? 1 minus cos squared x. So you know that sine squared theta is so I'm supposed to have the x here. You know that sine squared theta is 1 minus cos squared theta. So I've written sine squared x as 1 minus cos squared x divided by what? Cos x. Cos x dx. So this will be equal to negative integral of, so I'm going to divide each term. Divide each term of this by cos. Divide 1 by cos, I have 1 over cosine x. Then divide here by cosine. Cosine divide cosine square, I have cosine x, then dx. So this is equals to negative integral. I will integrate each of them. Negative integral of 1 over cos x, right? Dx. Now, because I factored out negative here, if I bring this integral, because I'm passing the integral, negative integral to each of them. If I pass negative integral to this negative here, it changes to what? Positive. So I have positive integral of cos x dx. Right? Then this is equals to negative integral. This 1 over cos is what? Sec x dx plus what is integral of cos? Integral of cos, if you integrate cos, you get positive sine x. So what is the integral of sec? This is equal to negative integral of sec is ln of absolute value of sec x plus tan x. So integral of sec is same than ln of absolute value of what? Ln of absolute value of sec x plus tan x. Then I have plus what? Plus sine x. So this is my a of x. I've got my a of x. Now b prime of x. Let's get the other constant b. B prime of x is equal to, what do you have here? Negative. B prime of x is negative a prime of x. What is a prime of x? See a prime of x here. A prime of x is negative sine square x divided by cos x. So if you put this quantity here, negative, I have negative here, I have negative here, I have positive. So I have positive sine squared x divided by cos x. So I've put this a prime of x here. But a prime of x is multiplying cos x. Multiplied by what? Cos x. Divided by what? Sin x. So I've written this b prime of x. So have it here. So this cancels. So this implies that my b prime of x is equals to, what do I have here? I have sine squared x divided by sin x. This implies what? My b prime of x is equals to, if you divide, sine divide sine squared, I have sin x. So what do? To get your b of x, you integrate both sides, because integral will cancel this derivative. So integral of b prime of x dx is equals to, integrate here, integral of sin x dx. So I've integrated both sides. So this integral will just cancel this derivative, this prime here, this derivative sign. So I have by b of x equals to, what is integral of sine? Integral of sine is negative cosine. Negative cosine of x. Therefore, our y of p, which equals a of x, which equals a of x cos x plus b of x sin x, is equals to, remember, from our equation 1, let me write this from 1. From equation 1, we have that our particular solution is a of x y1, where y1 is now is cos x, as I showed you, b of x y2 is sin x. So now we substitute. We have gotten our a of x. What is our a of x? Negative ln absolute value of sec x plus tan x, right? Then plus sin x multiply by what? Cos x. This is my a of x multiplying cos x. So this is my a of x multiplying cos x. Plus, what is your b of x? B of x is negative cosine of x. So I have negative cosine of x multiplying what? Sin x. Sin x. So if you open this bracket with cosine, this will be what? This will be equal to negative ln absolute value of sec x plus tan x absolute value multiplying what? I want to use this cosine to open this bracket, multiplying cosine of x plus cosine will multiply sine x cos x plus, then this one will have here negative cosine of x sin x. So what will happen? This will get cancelled with this. This will be equal to what? Negative ln absolute value of sec x plus tan x multiplying cos x. So this is my particular solution. So when you are solving a non-homogeneous second order ODE, you have to get your complementary solution and get your particular solution. The general solution is your complementary solution plus your what? Particular solution. That's y sub c plus y sub p. So this will give me the general solution. So the general solution to this to that non-homogeneous ordinary differential equation is y of x equals y sub c plus y sub p. What do we get from y sub c? From y sub c, we that's the first, when we got our complementary solution, we got c1 cos x plus what? c2 sin x. This is what we got for the complementary. Plus, then the one of particular solution, This is the one of particular solution plus negative ln absolute value of sec x plus tan x multiplying cos x. This gives you the solution to this very non-homogeneous ordinary differential equation. I hope this class is interesting. I'm expecting you in our upcoming class. Bye.